I quite like teaching this topic because what I get people to do here is I get them to start by just going, well, let's just do a over x squared plus b over x plus 1. And I get them to work out these two and then add them together, and you go, oh, it doesn't work. It's a shame we're not doing that. The other thing we then get them to do is we'll say, well, okay, so we've got an x squared there. Surely that's got a factor of an x and another x. And say, try and work out that one there. But the issue of this is that the common denominator of these three things is not this one. It would just be x and x plus 1. So we have to put a squared in this one here. Either of them there, but the question wants the squared in that. Now, the next error that people make is they put too many bits on the top here. This x only needs another x and an x plus 1 to get to the other denominator. And so you only need an x and an x plus 1 on the top, not an x squared. The b's already got an x squared. The only thing it needs is an x plus 1. It doesn't need another x. The c needs an x squared. And so now, repeating what we did in the other exercise, when x is equal to 0, I get 1 equals 1b, and so b is equal to 1. X is equal to minus 1, put a minus 1 in there, and I'm getting 3. And minus 1 here makes 1 again, so c is equal to 3. And the nice thing to do next is to count the x squareds, or later x cubes, or something like that. Here, there are just 3 x squareds. Here, there's some x squareds, and there's a of them. Here's some x squareds, and there's c of them. There's no x squareds coming from that thing at all. But we already know that c is equal to 3. So it turns out that a is equal to 0 in this example. Personally, for question 1, I wouldn't have an a is equal to 0, but there we have it.